Now we're going to talk about the indeterminate powers. Well, first of all, we should determine which are the indeterminate powers. It is when 0 is to the 0 power, infinity to the 0 power, and 1 to the infinity. Well, we should see this as a function that is elevated to another function. In this way, we can use the rule of natural logarithm in order to take down the second function and multiply it by the logarithm of the base function. Now we're going to make a small example in order to explain this subject. Well, in this example, we need to evaluate when x approaches infinity of e to the x plus x all to the e over x power. Well, if we evaluate this, it would be e to the infinity plus infinity over 1 to the infinity. That is the same as writing infinity to the 0. Well, in this case, this is an indeterminate power, so we should apply the L'Hopital's rule in order to solve this. First of all, we should identify which is going to be our y function, that it's e to the x plus x, all to the 1 over x. So we rewrite the function. And now we can apply the natural logarithm rule. So we rewrite the function with natural logarithm. We use this in order to be able to apply the L'Hopital's rules. It's natural logarithm of e to the x plus x all over x. And now you can see we can apply the logarithm rule with the limit when x approaches infinity. That's important. So we apply L'Hopital's. Its limit when x approaches infinity of 1 over e to the x plus e times e to the x plus 1 all over 1. And this is the first derivative of the first function I wrote. Now if we simplify this, is e to the x plus 1 over e to the x plus x. This is when the limit of x approaches infinity. Now we should rewrite this in the following part. Okay, so the limit when x tends to infinity of e to the x plus 1 over e to the x plus x is the same as writing infinity over infinity. So, as we mentioned before, this is a clear example where we should use L'Hopital's again, because it's an indeterminate function, infinity over infinity. So we apply L'Hopital's again, we rewrite the function, and we take we derivate both. So it's e to the x over e to the x plus 1. So if we evaluate this again, it will be the same as writing infinity over infinity. E to infinity plus 1. It's the same as infinity over infinity. So we have to apply the L'Hopital's rules again. We can apply this rule anytime that it gets an indeterminate answer, like infinity over infinity or minus infinity over minus infinity. So e to the x and e to the x is the same as 1. So 1 is our answer, and this is when the limit when x approaches infinity. But this is only the natural logarithm of y. So we should continue with the process. We already know that the limit when x approaches infinity of natural logarithm of y it's equal to 1. So we should use this answer in order to know when limit of x approaches infinity of only y. So this is equivalent to write limit of x approaches infinity of e to the natural logarithm of y. So we already know what is the natural logarithm of y, that it's 1. So we just substitute in the new formula we have specified. So limit when x approaches infinity of e to the 1 is equal to e to the 1. So it is e, the answer. We can use this process in any other one, knowing that natural logarithm, it's only the power of e. Thank you very much.
Well, to resolve this expression by L'Hopital rule, the first thing that we need to know is that to apply this rule, the values must be indeterminate. So, for example, infinity over infinity, 0 over 0, infinity minus infinity, 0 multiplied by infinity, 0 to the power of 0, infinity to the power of 0, and 1 to the infinity. So, the rule of L'Hopital is that the limit when x approaches to a is the first derivative at the top and then in the bottom. So the second step is that we need to subtract this expression to apply the rule, and it will be 1 minus cosine of 3x over x squared, and then we evaluate, and when we evaluate the expression 1 minus cosine of 3, we obtain like 0 over 0, so we can apply the rule. And the third step is get the derivative of the top and then to the bottom. So it's 3 sine of 3x divided by 2x, and then we evaluate and we obtain an indefinite value. So we need to apply the L'Hopital rule again. So is limit 9 cosine of 3x over 2. This is the second derivative of this one. And then we evaluate, so we get 9 cosine of 3 over 2, and we obtain 9 over 2. And this is all that we have to do, and thank you.